Okay, so the concert organizers use this data to model future number of visitors. It is assumed that the average number of visitors per concert will continue to increase by 1.2%. Determine the first year in which this model predicts the average number of visitors per concert will exceed the total seating capacity of the concert hall. Okay, so I brought in S20 is 660. This is the total capacity of the concert hall. And in 2019, there was 584 people, so we know that. Okay, so what am I doing? Okay, part C. Part C. Okay, so the first year it will predict to be more than 660. Okay, so we know in 2019 there's 584. And then in 2020 there's 584 times 1.012. Then in 2021 there's after times by 1.012 again, and I keep going and I keep multiplying until I get to a number which is bigger than 660. Now you can actually do it the kind of long way and just make sure you show that make sure you show all your working and that one value is less than 660 and the next value is bigger than 660. But certainly the more technical way to do it is we say, where is 584 times 1.012? When is this to the power of n? Because I multiply by 1.012 as many every year. So as many times as I need to get over 660. So when is this bigger than 660? And then using the calculator, I can just do NSolve. I can do menu, algebra, numerical solve. 584 times 1.012 to the power of n equals 660, comma n gives me 10.256. So that means n has to be greater than 10.256. But n is an integer because we're talking about the first year, the second year, the first term, the second term. Therefore, n has to be equal 11. So when n is 10, it's going to be less than 660. And when n is 11, it's going to be greater than 660. But the question says the first year. So what year is it? Well, if you think about it like this, these questions are always confusing as you have to like take your time to get it right in your head. When n is 1, that's 2020 because we multiply by this once was 2020. Twice will be 2021. 3 times 2022. 4 times 2023. You can keep going like that until you figure it out. But 11, it's always one behind, so 11 will be 2030. So therefore, first year is 2030. Okay. Part D. It says, it is assumed that the concert will host 50 concerts per year. Use the average number of visitors per concert per year to predict the total number of people expected to attend the concert hall from when it opens until the end of 2025. Okay, first thing to note, guys, is it's not going to, the average doesn't pass 660 until 2030, and we're only going to 2025, so we don't have to worry about this, because that would add an extra kind of layer of complication to it, because you'd have to stop increasing it, because it wouldn't increase. But we don't have to worry about that because it stopped at 2025. Okay, the average number of people in 2019 is 500, and 2019 is 584. 584. The average number of people in 2020 is 584 times 1.012. The average number of people in 2021 is 584 times 1.012 times 1.012 again, which is this squared. I'll do one more. 2022 is 584 times 1.012 cubed. So what we have here, guys, if you can spot it, is a geometric sequence. It's this times this, then we times this again, times this again. So the common ratio is 1.012. And essentially what we want to do is we want to add up all these, because this is the average number of people that visited in 2019, average number of people in 2020, average number of people in 2021, and they want us to predict the total number of people from now until the end of 2025. So I need to add up all of these. And then, just be careful, it says it is assumed that the concert hall will host 50 concerts per year. So whatever I get, I need to multiply by 50, because this is just the average number of people per concert, but there's 50 concerts, so I'm going to times by 50 at the end. Okay, so the sum of a geometric sequence, guys, in the formula booklet is u1 or to the n minus 1 and or minus 1. Our u1 is 584, that's our first term. Our common ratio is 1.012, that's what we're multiplying by. And our n, well, let's figure out our n. This is 1, 2, 3, 4, and then I have 23, 24, and 25. So that's 1, 2, 3, 4, 5, 6, 7. So there's 7 terms. So I'm looking for S7. That's 584 times 1.012 to the power of 7 minus 1 over 1.012 minus 1. Let's use our calculator for this for sure. This is, let's use this function, 584 times 1.012 to the power of 7 minus 1. 1.012 minus 1 gives me 4238.15. 4238.15. Okay, I've actually done this here. Nice and handy. So this is 4238.15, but it is 428.15, but we want to round to the nearest integer because we're dealing with people. So what I'm going to do is I'm going to round this to 42385. Now actually I'm not going to do that, guys. I'm not going to round to 3 significant figures yet, because I am going to multiply now this 4238 by 50, because remember what I said, there's 50, this is the average, this is the total per concert. So if there was just one concert per year, this would be the total, but there's 50 concerts per year, so I'm going to multiply by 50. So it's 4238 times 50 gives me 211,900. 211,900. If I want to give that to 3 significant figures, that's 212,000, 3 significant figures. Okay, that's it, guys. That is question 3.